Hello dear students, our today's topic is carbylamine taste, which is also called as carbylamine reaction and is also known as Hoffman isocyanide synthesis. This reaction is particularly used for identification of primary amine, and this reaction is not given by secondary and tertiary amine. I repeat once again, very important point to remember that this reaction is given exclusively by the primary amine having the general formula RNH2 and ARNH2. Whether it is aliphatic amine or whether it is aromatic primary amine, both gives the positive carbylamine taste. Look at the general reaction. In the general reaction, the starting material is RNH2, which is called as primary amine, which react with CHCl3, a very popular compound known as chloroform. The reaction takes place with 3 moles of alcoholic potassium hydroxide. The reaction is just require simple heating, whereby there is formation of R and C plus 3 moles of potassium chloride and 3 moles of water molecule. The product obtained here is called as isocyanide. So carbylamine taste simply gives the formation of isocyanide from primary amine in presence of chloroform and alcoholic potassium hydroxide. It is very easy to identify the isocyanide, though it has foul smell. Now the question is, what is carbylamine? So isocyanide is called as carbylamine. If you look at the starting material RNH2 and the product RN triple bond C, you will find the simple difference here is the presence of 2 hydrogens and here is presence of carbon. You may simply say that the carbon substituted these 2 hydrogens. That means the carbon is present over here as an alkyl substituent. So it is carbon, so we suffix it with YL, so it will become carbyl, right? And this carbyl is obtained from the amine, so it is called as carbylamine. Easy, isn't it? Okay, let's look some examples. Here we just change the alkyl group. First we will start with CH3. When CH3 is attached with NH2, it is called as methanamine. So by the reaction of methanamine with chloroform and 3 moles of potassium hydroxide, we will obtain here the product methyl isocyanide. So this is the carbylamine obtained in this taste. Methyl isocyanide is also called as isoacetonitride. So starting with methanamine, we will get the product methyl isocyanide. If an aromatic substituent is taken here, for example, a phenyl, right? So phenyl attached with NH2 is called as aniline. This is also one of the example of primary amine. So aniline on treatment with chloroform and alcoholic potassium hydroxide gives the formation of phenyl isocyanide. We just needed to change the R group over here. So in this case it is AR, aryl substituent, and it is called as phenyl. So the product obtained is phenyl isocyanide, which is also called as isobenzonitrile. So for this reaction, these two examples are sufficient. We will move on to the next and very important part of this reaction, that is its mechanism. So let's see how the carbylamine formed during the reaction. Our starting material is CHCl3, that is chloroform, and in the reaction there was presence of alcoholic potassium hydroxide, which is source of hydroxide ion. So we have the hydroxide ion in the solution. The hydroxide ion will attack on this hydrogen. Here is 3 chlorines are present. All the chlorines are electronegative elements, so they attract the electron pair towards themselves. Now when the hydroxy group take this hydrogen from this electron pair will be get shifted towards carbon. When this electron pair is getting shifted to a carbon, one of the chlorine along with its electron pair departs from here. So during this we will get formation of water from here. There is release of a chloride ion, and there is formation of very important species. This one, which is called as dichlorocarbene. Now in case of dichlorocarbene, the carbon is surrounded with only 6 electrons. 2 this electron which are left over by the hydrogen, 2 from this bond and 2 from this bond, so total 6 electrons are there. So this dichlorocarbene is electron deficient. It is in need of 2 electrons to complete its octet. So dichlorocarbene will behave here as electrophile. So this is very important part to find out that the species, electron deficient species, the electrophile generated in this reaction is dichlorocarbene. Now this dichlorocarbene, for the sake of electron, will attack on the nitrogen of the primary amine, because this nitrogen has a lone pair of electron on it. So the dichlorocarbene attack on this nitrogen. An intermediate which is formed by this attack is this one. So in this way the octet of this carbon is going to be complete out. This nitrogen will acquire a positive charge now. So positive charge means nitrogen is no longer electronegative now. So to retain the electronegativity, this electron pair will be attracted by the nitrogen, and this hydrogen as H plus now migrated over this carbon, because now this carbon has the electron pair on it. So ultimately, due to this, we will get this species now. Now whatever the species are there, they are under continuous influence of the hydroxide ions. So hydroxide ions play a very important role in this reaction. The hydroxide ion take up the hydrogen which is attached on the nitrogen. Nitrogen is electronegative, so it attracts the electron pair towards it. So when the electrons of this bond are shifted towards nitrogen, and when this bond is being broken down, this bond is going to start to be formed, during which one of the chlorine expel out from here. So we will get formation of this species. Now this species is also under the influence of the hydroxide ion. So now this hydroxide ion will take up this hydrogen. So hydrogen leaves this molecule by giving this electron pair to the carbon. So when the electron pairs are going to be shifted towards carbon, the chlorine with its electron pair of this bond tends to release out from this molecule. So here is the formation of our N double bond C with electron pair given by the hydrogen. So this species is very important species which is formed over here. If we look at this structure, we will find that the carbon is now surrounded with 6 electrons. So this structure is now converted into somewhat different structure where this nitrogen share its electron pair with this carbon through a coordinate bond. So the compound form over here is this species, and a coordinate bond is formed between the nitrogen and the carbon. As the nitrogen share its electron pair with this carbon, there will be a coordinate bond. So ultimately we will obtain this product which is called as alkyl isocyanide. So that is all about the mechanism of this reaction. Thanks for watching the video. Please like it, share it, and don't forget to subscribe. Thank you.